So hello everybody, my name is Christoph Mussenbrock. I'm one of the co-founders of EtherRisk. EtherRisk is building a parametric insurance platform on Ethereum. And I want to show us our latest development. We have actually developed a generic framework where anybody can build parametric insurance solutions on Ethereum in very short time. It's basically something like a Linux for insurance in the Ethereum blockchain. First of all, what is our mission? Our mission is to develop a decentralized insurance platform. What means decentralized? Decentralized means that we break up the value chain. In the traditional insurance, the insurance company is responsible for all aspects of the value chain, from the distribution to underwriting, managing the policy life cycle, claims management, and all these things. And in our solution, we can break this up and we can enable many participants to collaborate on an insurance product. For example, some people can do the distribution, some people can manage the policy life cycle, other people can provide the data for the claims management and do the payments and so on. So we break up this chain and enable collaboration. To do this, we need a way to interact, and therefore we implemented a common infrastructure, and people can build with very little effort their own insurance products. And so they do not need to program all the aspects of an insurance product, which is very complicated, but they only need to concentrate on the product-specific parts like pricing or the business rules for claims management and so on. And because we are focusing on parametric insurance, we provide a way where the insurance products are much more transparent and fair, and that is what Alexander already mentioned. Parametric insurance removes the indeterminism of the claims management, where people never know if their claim is accepted or not. And parametric gives you an objective measurement whether you get a payout or not. So our solution, we have a complete set of smart contracts which manage the complete life cycle of an insurance policy. And we use oracles to get the data for the pricing and also for all other aspects of the value chain, including the claims process. And of course, we can model these processes individually per product. Products have different types of life cycles, and our platform is flexible enough to manage all these different types of life cycles and business processes. Essentially, we have a very small business process engine incorporated in our framework, so the process can be modeled individually. And the collaboration of these participants, which can be many in a certain product, is also orchestrated by the use of a token. The token actually serves as a medium to coordinate the interaction of the participants in the value chain, and, for example, to ensure service levels and to ensure the correct behavior of all the participants, so that the product itself is reliable and also predictable for the customer. The examples which we have, this is our version of flight delay, which is in many aspects very similar to Fizzy. And we are using the same oracle and the same data provider, FlightStats. And if you like to use it, then you can use our demo, which is on the slide here, fdd-demo@etherit.com. And this product was live and as a license insurance in the last year as a market test. And currently we are talking with some German insurers to bring this to a new scale. And of course, the regulatory aspects are difficult, and full respect to AXA that they managed to do it in their corporate environment. I know what that means. We have a second example, so-called weather-based insurance for crop. This is going to be live in April and May. It's crop insurance for Sri Lanka. In Sri Lanka, you have these unpredictable weather events. They have monsoon, and twice a year the monsoon will bring rainfall, but it's not very predictable, and farmers depend on the rainfall, so they need an insurance. And there is already an insurance product, but it's very difficult to use because it's paper-based, and we will automate the whole process, and we will also connect Weather Oracle to the claims process, so the farmer does not have to file a claim, but the payout is done automatically. In the same way, we have Hurricane Guard that is in Puerto Rico, team working on this. It's based on wind speed, and so as soon as the wind speed is above a certain level, then the contract will trigger an automated payout. And of course, we have much more ideas what we can realize, and but first of all, we want to start with these 3 examples to bring them to the life, and then we will see what we can do else. Now, the architecture of our platform, it's actually a set of smart contracts, and to manage these smart contracts, we have a set of microservices which run in the cloud. The smart contracts are basically in 3 layers. We have a base layer, which is the basic business engine and business logic of a policy lifecycle. These are the blue boxes in the bottom. And these are provided by our decentralized insurance foundation. The decentralized insurance foundation offers these software for free as open source. You can go on GitHub and copy it and run it if you like. And we have also some green boxes, which are elements which we develop together with partners like payments providers. These are sometimes open source, sometimes proprietary, depending on the partner. And on the top, the yellow boxes, these are the pieces which the product owner will create. These are only small smart contracts which incorporate the product-specific parts, pricing, claims management, business rules, which are product-specific. And in the background, the microservices are used to manage all these smart contracts. Our experience from 2 years of running the system is that smart contract is nothing which runs for itself. It needs to be monitored. You have bugs, you need to upgrade it, and so this microservice infrastructure behind enables you to manage these smart contracts in a very convenient way. So the smart contracts, the core smart contracts, as I said, they implement a generic workflow for a policy. They provide services to store data, to anonymize data. Of course, we need to respect the data protection laws in Europe and other countries. We have payment functionalities. We have, of course, oracles. And we have all the framework which you need to upgrade smart contracts in case the product needs to be modified. The pricing is changed, and you need to upgrade these contracts, and all this stuff is done by the core smart contracts. Of course, the whole thing is multi-tenancy, so many different parties can work on the same platform, and the data is kept separately, like in a big cloud structure. So actually, this is insurance as a service, and it has the whole policy life cycle from application, underwriting, payout, and until a policy is finalized or ended because of expiry or other reasons. So you see here the data flow. In the yellow box, there is again your application-specific code, the pricing and business rules for all the product-specific aspects, and then you needs to talk only to one central interface. This is the so-called product service contract. This product service contract has functions which you can call to manage the whole life cycle. So it's very easy. The product service contract also offers you methods to authenticate and to verify if the right people are calling these functions. So we can verify if, for example, the product is registered in our system. Not everybody can just deploy a product, but he needs to register, because we have to make sure that only products are run on our platform which are compliant to the regulatory requirements. And then the business flow is handled in the policy flow handler, which actually manages the different states of a policy from application until expiry. And all interaction with the external world is done via oracles, and to make it convenient for our products, we have created a so-called query broker. The query broker is actually a generic interface to many types of different oracles. So we can use Chainlink, we can use Oraclize, we can use product-specific oracles which are created by the product itself. And the query broker provides a unified interface, so we can handle all these calls in a unified way. This is a query broker. In principle, you issue a query to the query broker, then the query broker will emit an event. The event is registered by different types of oracles. The response is routed to the query broker, and the query broker will then call back the calling contract and deliver the data. This is nothing special. It's just actually a proxy to different types of oracles to provide a unified access. The interesting thing is here that we can link our DIP token in this query broker, because in our way to see the world, we say that the value is always created outside the blockchain. Yeah? So if you have some computation on-chain, it's actually not value creating. If you add some numbers or if you make decisions on blockchain, that is not creating value because it's just running code. But the actual value is created outside the chain by data providers and people who, for example, do a claims management. So the query broker is the right place to measure this value and to also to price it and to do the payments for these services. And the DIP token comes into play, because the DIP token will be needed for everybody who uses the platform. He needs to have and hold some DIP tokens in proportion to the revenue he generates on the platform. And so we create a demand for our DIP token, and so we run our DIP token economy at a single place in our framework. Yeah, this is another example how we use a token in the framework. Imagine you have a flight oracle which provides flight data, and of course you as a product owner, you want to have a reliable oracle, and so you make a contract with your oracle provider and you say, I will pay you, but you need to actually stake a collateral for the case that you do not deliver and you do not fulfill your service level agreements. Because in this case, if you don't deliver the data, then I need to use a backup, and so that it creates additional cost, and you have to reimburse me for this cost, and you do this by giving me your stake tokens. So this is a different use of our DIP tokens, that we use DIP token for staking and in case of not fulfilling the service level, then people will lose their staked tokens. And this is done in a central place in the Oracle broker, and so we have one place where we can manage all this token economy, and that's also very convenient for the product builders because they have one single place where they can manage all the payments to their service providers. Now the microservice level, we have a standard microservice infrastructure with a message queue server in the middle, and the message queue server interacts with the different microservices and acts as a hub between the different message types. And so a product-specific contract can issue a message, then it is routed with the message queue servers to either the core contracts or the third-party contracts. And this infrastructure is not rocket science. It's using very standard components. We use RabbitMQ and Kubernetes. And the nice thing of this message queue infrastructure and microservice infrastructure is that it can be dynamically extended by new services, new message types. And so it's very flexible, and that corresponds to our open approach in the smart contract side. And of course, the core microservices provide all the methods which you need to interact with smart contracts, monitor them, and get information out of them. So this is a list, and also this is also public in the GitHub. You can download it and run it if you like. And yeah, we have additional microservices. You see the payments. We have gateways to credit card providers like Stripe. We can also trigger payments to other or to customers via TransferWise. So you can use these services, and the whole payment stuff is also very convenient. As said, we need to monitor all these smart contracts, and we will also offer a monitoring service. So you have a user interface, a web interface, where you can directly see what's happening in your smart contracts. We have about 20 different smart contracts, so it's not easy to track them via Etherscan. You need some web interface to see what's happening, and our monitoring system will provide this insight, and you can use this for customer service. If somebody calls you and asks what is happening with my policy, I did not receive my payment, can you please check this? Then the monitoring system will give you all the necessary information. And of course, we will provide developers with a sandbox, because of course you can clone the GitHub and you can install all the smart contracts, deploy them on a testnet, run them, but it is actually a lot of work. And to get everything running, so to make it convenient for developers, we will provide a sandbox where everything, the core framework of smart contracts and core system of microservices already running for you, and you can just deploy your small product-specific smart contract on top of it and run it, and so you can directly see what's happening, and you don't need to care about all the operational stuff which we do for you in the background in the sandbox. And the sandbox is actually one instance of a productive system which we will, for example, use for the weather index insurance in Sri Lanka. Now, that's all. Questions?
Thank you for your presentation. I'm wondering, who do you believe that your system will be white labeled to insurance parties, or how who do you call up as an insured person?
Yeah, actually there are many different operational modes. First of all, we are currently establishing a commercial entity which will run a productive instance of the framework, and which is open to people who want to use it and will build their product upon it. So this is this is one approach. Of course, we are happy if others also take this opportunity and run instances of this framework on their own. Currently, I don't see so many people who can do this, because we do not need only technical knowledge and expertise, but you also need a lot of insurance know-how, and of course all the stuff with regulations. And so we provide this out of the box for you, for people who are interested. And of course, we run our own products on this platform. And so our self-understanding is that we are not only technical providers, but we are also full service providers for all the non-technical stuff. And so if anybody will copy this, and we are happy to do and help them, but actually we expect that for the first time, we will probably be the only one to provide this full service. Yeah.
The technical framework is quite the same, I would say, for insurance and gambling. Why don't you try to extend your service to, for example, peer-to-peer betting or gambling systems?
Yeah, actually, of course, insurance has always had some similarity to betting because we are dealing with risk, but in contrast to gambling, we are not increasing the risk. Yeah? So if you are doing a bet, then you increase your risk. Yeah? You put some money in the fire. Insurance is the contrary. You want to reduce your risk. Yeah? And so actually, we are focused on insurance only. But if somebody finds our stuff useful for implementing a gambling platform, then he's free to do so. It's open source, after all. Yeah.
I'm wondering actually if you have thought about use cases that are blockchain specific. There are a lot of lost funds from ICOs and similar thing, and I want to pick up your mind. What are your thoughts? Is this insurable or is it hard because it's risky?
Yeah. Absolutely. We have also looked after blockchain-specific stuff. Some people, for example, have proposed that we insure CDPs of Maker. If your CDP is not fully collateralized, then it's in a danger of being liquidated, and an insurance could step in and collateralize it and protect the CDP from being liquidated. That is some use case, but that would only work if we would have many different underlying assets, not only Ether, because otherwise all the risks would be fully correlated, and that's not a good case for insurance. But of course, these are use cases, and we are also looking for other places where we could use it, and we are also looking for applications which are risk transfer, but which cannot where we can avoid it being an insurance. Yeah? So we have some use case where a close user group puts some money in a central pool and insure mutually against a risk. For example, you could imagine a proof of stake blockchain, and people who are staking, they insure against the risk that their node is breaking down, and they lose money because their node is away for some time. This will become very interesting if Ethereum moves to proof of stake and people have a lot of money at stake. And so these are applications, and we expect that we can build these applications maybe even without an insurance, with having it in insurance in a legal sense. So we would avoid the whole regulatory stuff, and it becomes much cheaper. So we are open for this. So of course, everybody's invited to invent some ideas, and we are happy to hear of this. Okay, thank you so much for having me. Bye-bye.